Alright guys, so today we're going to be looking at how to graph exponential functions, also logarithmic functions. Both of those we're going to be graphing. But they're not just going to be basic ones, we're going to be having transformations with them. So remember, an exponential function is a times b to the x. A is not allowed to be 0. B has to be a positive real number other than 1. Logarithmic function, how is y equals b to the x rewritten as a log? All right. Well, if I want to rewrite this as a log function, it would go like this. I would say that I'm going to say log, find the base, go over to the other one, and then back to the exponent. So to rewrite this as a log, here's the way it would look. So these two would be equivalent to one another. So if I had a problem like this, I could rewrite it as an exponent and make it so that I could find values more easily. We'll talk about that in a minute. All right, transformation review. We've done this many times. If I want to move to the right 3 units, x gets replaced with x minus 3. If I want to move to the left 2 units, x gets replaced with x plus 2. That's what this is saying right here. If we want to go up, the entire function, we just add that value to the function. So 5 up, 1 down. If we want to go over the y-axis, x gets replaced with negative x. If we want to reflect over the x-axis, then the entire function gets multiplied by a negative. If we want a horizontal shrink by a half, x gets replaced with 2x. It's a reciprocal. If we want a horizontal stretch by 2, then x gets replaced with 1/2 x. Vertical, if we want to stretch by 3, the entire function gets multiplied by 3. If we want a vertical shrink by a fourth, the entire function would get multiplied by a fourth. So with verticals, it's the entire function that gets multiplied. When it's horizontal, it's just the x that gets replaced. All right. Remember that the key points for an exponential function are 0, 1, and 1 base. Here's the reason why. Anything to the 0 power is 1. Anything to the first power is itself. Remember, the asymptote is y equals 0. So we're going to look at these functions, and we're going to find the new key points. So looking at x and y, normally our key points are 0, 1, 1 base. But now we're going to see what happened to this. Right here, x got replaced with x plus 3. That's a shift to the left, 3. Then we have a shift down 5, so I'm going to subtract 5 from these. These are my new key points. They are -3, -4, and -2, -3. Now, the other thing we have to remember is that we had this asymptote of y equals 0. So y equals 0 is here, but it got shifted to the left 3. That doesn't change it. It also got shifted down 5. I'm going to call this 2. 2, 4, 5. Here's my new asymptote. My new key points, I'm going by 2's, so -3 is going to be, there's -2, -3. There would be -4. There's -2, there would be -3. I'm never going to cross that asymptote. We just get closer and closer to it at the end. I might want to find my y-intercept. If I plug in 0 for x, I'm going to get 2 to the third, which is 8, minus 5 is 3. Kind of good to have that point too. All right, and that's the way it's going to look. If we want to check that, we can always check it on the calculator. We just go to our calculator. We're going to put it into y equals. See if we can get 1 out of here. So I'm going to put it in here, and we've got 2 raised to the x plus 3 minus 5. I'm going to look at my table of values. I should see -3, -4, that's good, and I should see -2, -3, that's good. So we're in good shape. That's the way it looks. If I want to take a look at it, I can do a zoom 6, and here I can see the function. All right. Oh, I went too high on that one. I forgot I went by 2s. 2, 3 would be right there with what I was using. That's why it looked a little too steep. All right, let's take a look at this one now. Key points, 0, 1, 1 base. However, oh, let me put this new asymptote over here. This would be y equals -5. All right, so back here we got 0, 1, 1 base, but x got replaced with -2x. What that's going to mean is I'm going to have to multiply these not by -2, but by -1/2. So I'm going to multiply this by -1/2 and this by -1/2. The other thing that's going to happen is we have to add 3, and we get this. All right, let's put our axes in there. So we've got the point 0, 4, and we've got the point -1/2 and 3.5. Normally on these functions, exponentials are asymptotes y equals 0, but this is going to be a reflection in the y-axis, and also it's going to be a horizontal shrink of 1/2, but that doesn't change y equals 0. We're also going to have it going up 3. That will change it, so it's going up 3. There's my new asymptote. So there's the way it looks. And so then my key points are right there, 0, 4, -1/2, 3.5. The asymptote is now at y equals 3. Okay? All right. We're just going to talk about what would happen on these. We're not going to actually graph them. But on this one, you should be able to know that the negative, replacing x with -x, is going to be a reflection in the y-axis. That's going to happen. Also, when x gets replaced with 1/2, we're going to have a horizontal stretch by 2, and it's going to go up 3. Let's go ahead and just get our key points. We're not going to graph. So normally my key points would be 0, 1, 1 base, but I'm going to have a reflection in the y-axis. That means that x is going to get multiplied by a negative. Then I also have a horizontal stretch by 2. That means these have to get multiplied by 2. And then we're going to go up 3. Oops, that would be 12. And if I just wanted to check those key points, I always like to do this, especially if this is on the calculator part. We might as well just check it and make sure that these key points are right, at least. So I see my key point of 0, 4, and then -212. So we know that's good. If you want to look at it, just let me show you the original, and let's look at what happens here. So we have our original function. 9 to the x is going to be a growth function. This is the decay function. This turns into a decay function because 9 to the x got reflected over the axis, so now it turns into decay. All right, just key points here real quick. 0, 1, 1 base. This means that I'm going to have to multiply the x's by -1/3. Because we have that reflection in the y-axis. So multiply these by -1/3, and then down 5. Okay, we'll just jot that down. These would be our new key points. We have a reflection again in the y-axis. We have a horizontal shrink of 1/3, and we went down 5. Okay? All right, now let's look at some equations where we're going to try to come up with the new equations. So here's our original function. The first thing we want to do is reflection in the x-axis. So reflection in the x-axis means I multiply the whole thing by a negative. So that's going to go out in front. Followed by a vertical stretch by a factor of 3. That means my whole function has to get multiplied by 3. That's my second step. So I've done this, And then the last thing is I have to go 2 units left. So to go 2 units left, everything stays the same, but x has to get replaced with x plus 2. And it says to write a rule for g, so that's what I'm going to call it. And there it would be. All right, on the next one, original function is e to the negative x. The first step, 2 units right. That means this x, watch this one closely, this x has to get replaced with x minus 2. Only the x, so the negative stays there and the x gets replaced with x minus 2. All right, so I'm going to go ahead and simplify that. Then I have to go 3 units down, and then a vertical shrink by a factor of a half. Now that's going to mean that my entire function has to get multiplied by a half. And so my g function now is going to be 1/2 e to the negative x plus 2 minus 3/2. That would be the g function. All right. Let's go over here. And now we're just going to be graphing logs. This is exactly the same thing. You want to go to the right, replace with x minus 4 to go 4 units right. Okay, if we want to go over the y-axis, x gets replaced with negative x. Over the x-axis, multiply the whole thing by a negative. All the rules hold true no matter what function we're looking at. This is the one people typically have trouble with. The horizontal stretch of 3 means x gets replaced with 1/3 x. A vertical stretch by 5 means the entire function gets multiplied by 5. All right, so remember, if you are given y equals log base b of x, that's the same thing as b to the y equals x. Therefore, the key points for this log function are going to be 1, 0, base 1. See, if these two are equivalent, which they are, I'm going to plug in 0 for y. b to the 0 is 1. I'm going to plug in 1 for y. b to the first is b. That's where these points come from. The asymptote on these is always going to be x equals 0. All right, graph the following, state the asymptote, key points, domain, and range. All right, so our key points on this are going to be 1, 0, base 1. I'll go ahead and graph this one. We've got 1, 0, and we've got 1/2 1. We have to have this vertical asymptote of x equals 0. So it's going to come down like this. It never can cross that. So this is the way the function should look. Okay. All right, looking at the next one. Oh, domain and range, all that. Okay, here's our key points. Key points are 1, 0, 1/2 1. Domain is going to be 0 to infinity, and the range is going to be negative infinity to infinity. All right, on this one, we know our key points that here are going to be 1, 0, base is 10, so 10, 1. If we don't see a base, it's 10. Now we're going to see what's happening. Well, we have this shift to the right 2, so I'm going to have to add 2 to these. And then we also have a vertical stretch of negative 3. I can just multiply by negative 3. I'll go by 2's because of that 12. So we're going to be at 2, there would be 3, 0, 2, 4, 6, 8, 10, 12. Negative 3 would be there. All right, we have this vertical asymptote of x equals 0 normally. X equals 0. But we're going to have to shift it. So this is going to shift to the right 2 as well. So now it's going to be here. And so this is the way it's going to look. Okay, so that's our function. Again, if I wanted to check that first one, I just want to show you this because this is a little different on how we would check it. You got to go to that log base. To find that, you got to go under math. You got to go way down here. You got to do that log base 1/2 of x. We're just going to go back and look at this one for a minute. Zoom 6. We're going to check our graph. Now see, if you just look at this graph, it looks like it stops, but it doesn't. It keeps going up. And then we'll just check our key points. We've got the point 1, 0, and we can't see that 1/2. Here's how I can fix that. I can set my table to start at 0 and go up by 1/2. And now I can check that 1/2. 1/2, 1, 1, 0. Okay, so we're good. All right, let's keep going. Oh, domain and range and everything. Key points here. 3, 0, 12, -3. Asymptote, vertical is at x equals 2. Domain is going to be 2 to infinity. See, this keeps getting closer and closer and closer to that asymptote. And the range should be -infinity to infinity. All right. This one, we're just going to get the key points just to make sure everybody's got it. We got x, we got g. Here's the original parent function, but we know that our key points for logs are always going to be 1, 0, base 1. Our base is 1/3. We're going to have a shift to the right 1 and up 2. Okay? We won't go any further with that. Let's find the asymptote actually. Normally the asymptote is x equals 0. If I have a shift to the right 1 though, now that asymptote is going to be x equals 1. It's going to go up 2. That doesn't affect that asymptote any, but and it won't affect anything else. But the domain on this one would be 1 to infinity, and the range would be still -infinity to infinity. All right, let's do these now. We have our original function. We want a reflection in the x-axis. That means that the whole function gets multiplied by a negative. There's our first step. Translation 7 units left means that wherever I have an x, I'm going to replace that x with x plus 7. That's my second step. And then finally, 3 units up. I'm just going to call it G. And that's that one. Okay, on this one we start with natural log of x. That just means we have that base of e. 2 units left. X gets replaced with x plus 2. 3 units down. Let's just go ahead and do that all in one step. Followed by a horizontal stretch by a factor of 5. Okay, so that means just this x, just the x, is going to get replaced with a 1/5 x. And that would be that function. All right, on this one, start off with, we want a horizontal stretch by a factor of 3. What do we do? All right, we replace the x with a 1/3 x. Okay, this one's going to be a little tougher, I think. Followed by a translation 5 units left. Okay, so in my next step, my 1/3 stays the same. This x has to get replaced with x plus 5. It would have to go like this. The x gets replaced with x plus 5. Everything still has to get multiplied by that 1/3. Simplifying this, it becomes log base 1/3 of 1/3 x plus 5/3. Or you could even leave it like this, but you have to have the parentheses. Here's what people will put sometimes. That's wrong. That is not correct. It must be like this or like this. And then the last thing we want to do is go 3 units down. So we're going to have g equals log base 1/3 of 1/3 x plus 5/3, and then 3 units down. And there we go. All right? So you've got to know those key points. That's something that's so important. For exponential, y equals b to the x versus y equals log base b of x. These are inverses of one another. They are, because look, if I want to find the inverse of this, y becomes x becomes y. If I rewrite this, log base b, swirl it around, of x equals y. This is an inverse, this is another name for this, and that's the same as that. So these are inverses of one another. And that's the reason why the key points, let's get rid of that now. The key points for this are going to be, key points for exponentials are 0, 1, 1 base. Whereas here, the key points, so for exponentials, this is it. For logs, what is it? 1, 0, base 1, right? X becomes y, y becomes x. See that? X becomes y, y becomes x. X becomes y, y becomes x. Here, remember our asymptote is y equals 0, y becomes x, so this one has x equals 0. That's kind of how you put it all together. All right, let's stop there.